And hello back, part 2, after the network meltdown. So now what I want to do is I just want to find the equation of the tangent line. I have that x is equal to 3 and that f of 3 was what? Negative, was 10, right? So I can find the equation of the tangent line. I wanted Mathematica to do it, but I'll find it by hand, and then I'll ask Mathematica to do it again. So we have this information. So y is 10, m is 9, x is 3, plus b. So b is clearly negative 17, right? 9 times 3, 27. 10 minus 27 is negative 17. So what is the tangent line? Y equals slope is 9. So 9x minus 17 is the tangent line. So what I did is I used the limit definition to find the slope. And the reason why I had to use definition is, if you remember, algebra fails. Algebra fails when you only have one x value, because it will be 3 minus 3, which creates 0 in denominator. So remember what the purpose of the limit was: to calculate the y value using all points except 3, right? So that's why it worked, because limit is calculating the value using infinitely many points around the point of interest. And we were able to calculate 9. So now we know that the slope of the tangent line is 9, and then we use just a regular algebra to find the equation of the line. You can use the point slope formula if you want, whatever makes you happy. Your happiness is the primary concern in mathematics, right? So use whatever formula makes you happy. All right, now let's try this again. See if we're going to have another meltdown. So once you're in Mathematica, use this, then we go into Wolfram Alpha query and say graph 2x squared. What was that? Plus 3x, no, minus 3x plus 1. And y equals 9x minus 17. I did not put y equals, or you don't have to, but whatever. All right, so this should return a graph with parabola, and you can clearly see on the bottom picture, which I will make larger. You can clearly see that at 3, x equals 3, there is the point of intersection between the blue line and the orange line. So x equals 3. Right there. X equals 3, that's where they touch. It's a tangent line, which means touches the function at exactly one point. And you can also see that that's happening at 17 because, sorry, that the negative 17 is the the y-intercept for the line. And the slope is 9. 9 units up, then over, 9 units up, and then over, and so on. So this is just a little confirmation. Now, Mathematica is extremely powerful, and Mathematica will do all the work for you. So it's a really good tool for you to use to check your problems. Now, you can obviously go and do the Wolfram Alpha, which is the part of Mathematica. But you can, if you have Mathematica installed, you can just say tangent line for 2x squared minus 3x plus 1 at x equals 3. So you can just talk to the software. The way you would say it to your friend, right, is the way you say it to Mathematica, and Mathematica goes and computes. So it should be okay, so it didn't work out. Did not understand my accent, I guess. So let's change the wording. Y equals, that's the only thing I'm going to change. So 2x squared minus 3x plus 1 at x equals to 3, tangent line. Let's kick out the word for.
Spelled tangent wrong too.
Ah, that's the problem. That's the problem. Tangent line. Yeah, that's important. There you go. Immediately gives you y equal 9x minus 17. See it? If you spell tangent correctly, then you get the answer right away. So here's the answer, and the same graph appears. You can make it larger and so on. So for your, labs and study time, if you are looking for answers, this will solve any problem in the textbook, just like that. Which is maybe not good, because you might resort to this rather than actually learning. If you use this responsibly, you'll have a very powerful tool to check your answers. Cool. So let's recap and then keep pushing. Make it better. That's lost. I'll get it eventually. So we are starting with the idea that the point Q is moving towards point P, creating all of these infinitely many secant lines. All of those lines can be computed using algebra. I mean, their slopes can be computed using algebra, and then the rest of the equation if you want to find the actual lines. The red line is called the tangent line, and that one cannot be computed using algebra because P and Q are at the same spot, which would make denominator 0. But we notice that all of the blue lines are leading towards the red line, which means that we can take the limit of all of those blue lines, and we would get the red line because they all go to that point, which is this x goes to a in the bottom. When you plug everything in, we get our M tangent. So now we know how to find the tangent line, how to find the slope of the tangent line first, and then how to find the tangent line. So our function was 2x squared minus 3x plus 1. Now what happens when someone will say, oh no, I didn't need that for 3. I actually need that for 5. What do? You go and you recompute the whole thing, right? And then the person shows up and says, oh, no, not 5. I meant 1.5, sorry. Right? So what that means? Recompute again, right from scratch. So is there a better way to do this? And the answer is hell yes. What we can do is we can do some mathematical manipulations and try and figure out the easier form that has less calculations, and then we are going to improve upon that twice after that. So first of all, can I improve this formula M tangent is the limit x goes to a of f of x minus f of a over x minus a. Can I improve that formula in any way so it's not so much computation? And the answer is yes. If you go and let age equal x minus a, that means that x is age plus a. We'll need all of these guys. And now we plug in. Well, first what I see here is that I can subtract a on both sides. So what I have is that the M tangent now becomes limit x minus a goes to 0. And then I have f of x is age plus a minus f of a has to stay as is, divided by x minus a. And now look what I have. I have that x minus a is age. That shows up twice. So this thing over here is age. And this thing over here is age. And over here on top I already have age. I just eliminated all of x's. So now M tangent is equal to limit age goes to 0 f of, I'll put a plus age, minus f of a, divided by age. This formula is much easier to compute. You don't have to find the polynomial twice and so on. Right? So let's use this formula now on the same problem and compute f of x is equal to 2x squared minus 3 x plus 1 at x equals to 3. Well, we need to know more math now because we have to deal with the function composition, this a plus age deal. Please. Refuel. So now what do I have? How much is f of a plus age? A is 3, right? So I have 3 plus x is going to be 2 times 3 plus x squared minus 3 times 3 plus x plus 1. And we simplify this. So that's 9, 18 plus 6, 12x plus... Why did I put x? This is age. Hold on. These are age, not x. Age, age, age. There we go. Plus 2age squared minus 9 minus 3 age plus 1. And we collect all the like terms. We get 2age squared plus 9 age, and then 18, 9, 10, plus 10. Now, those of you who remember the difference quotient, you see that's the difference quotient formula from the pre-calc 1. You just seen the derivation for the difference quotient formula right here. The one that you were supposed to memorize in pre-calc 1 and use it for no apparent reason. Now you see the reason. Alright, so M tangent. M tangent is limit age goes to 0 divided by 2age squared plus 9age plus 10 minus f of a. That was that 9? No, 10. Divided by age. Let me go all the way back. Yeah, minus 10. Because they have to cancel. And then these guys will drop. You will be able to factor out age. Leave 2age plus 9. The age now dies off, and when h goes to 0, you get 9. Now you might say, well, hold on, this is not shorter, this is longer. Yeah, but this is the intermediate step. You still have to redo and recompute everything if I am to change from 3 to 5, because that changes 3 to 5, then 5 and 5, and then everything changes here, and this changes as well. So it becomes longer. It becomes longer. Meaning that you have to constantly recompute. Every time you need to find a new tangent line, you would have to recompute. Now you're still wondering, why are we computing these tangent lines? Hold on that question, all right? Let's just agree for now that we must compute these tangent lines. They do something. So, how's the progression so far? Let's recap and then make it even better. So the first idea was slope of the secant line was good old y2 minus y1 over x2 minus x1, which we could also write as f of x2 minus f of x1 divided by x2 minus x1, and I used x and a in that form. So that was that. Then we got that m of the tangent line was given as the limit as x goes to a of f of x minus f of a, x minus a. That was the next step in evolution. And you have to recompute and recompute and recompute. And then we did a little bit better by using the substitution, and x minus a was h, and then came to this formula, which has a little bit less computing and less factoring and less algebra, but still you have to recompute every single time. But then we realize something. We realize that a could be 3, could be 5, could be 1.5, could be whatever we need to know. So why not write x instead of a? Compute the limit in general terms, and then once we get the answer in terms of x, just keep plugging 3 or 5, then you don't have to recompute. So what I'm going to do now is I'm going to define that a as x as a variable, and I'm going to do the limit for the tangent line in terms of x, not in terms of individual numbers. Remember over here that we did for individual number? You see how we plugged in 3. So that 3 was propagating through the whole problem, and the whole problem becomes dependent on 3. That's really bad. That's almost as bad as let's say Apple, like Apple technology in quotation marks, right? It's exclusive only for their garbage platform, and that's it. It's not compatible with anything else, and if you're not buying from them, it just doesn't work, right? So what's happening is now what I'm going to do is I'm going to make it like open source, all right? What I'm going to do is I'm going to say that the tangent line, right, m tangent, is going to be the limit h goes to 0 of f of x plus h minus f of x divided by h. And this is the boss equation. Because now, with a single calculation, you are going to compute all of the slopes that could possibly be computed for that function. So let's go back to our problem. Again, the same problem. It really doesn't matter what the problem is, right? But we are using the same problem, and I'm not telling you where. At x equals all numbers, all right? So I'm using not a as 3 or 5. I'm going to say all numbers possible. So now, what I'm going to do is I'm going to say, okay, limit age goes to 0, and I have 2x plus age squared minus 3x plus age plus 1. I'll put that, maybe I should, let me use brackets so we separate these guys. There we go. Minus 2x squared minus 3x plus 1. Everything divided by age. So if you carefully look at the definition and the problem, f of x plus age is the first bracket, f of x is the second bracket, which is just Control C, Control V, right? Copy and paste. Copy and paste. And then divided by age. Just grind through this algebra in one step, and you will see what happens. The most amazing thing happens. It's going to be a little bit of writing there. We have 2x squared plus 4x age plus 2h squared. If you don't believe me, you just FOIL it on the side. I know the quadratic formulas and stuff, so I just use that. This was the square of binomial. Minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1. Everything over h. And then you see how these guys are pair. They cancel. These guys are pair. They cancel. And these, not that one. These guys are a pair. They cancel as well. So red with red, blue with blue, and purple with purple. You are left only with terms that contain age, which means that you can kick the age out. You kick one age, you are left with 4x plus 2h minus 3. Divided by age, and now that problematic age in denominator drops as well. When age is equal to 0, the middle term dies, and you are left with 4x minus 3. Your answer depends on x now. Now this is huge. Answer is a function. So, when we use the first two iterations of this formula, we had to plug in 3 and get 9. But we said, let's just try to use general x instead of 3 or 5. What happens in that formula when you plug in 3? You get 9. See that? Understand this. This formula will generate any tangent line slope. If you need it at 1, plug it in. 4 times 1 minus 3 is 1. If you need a negative 10, it's going to be negative 43. So this formula, this function, and this is crucial part here. So now, this function, I'll just put 4x minus 3 in parentheses, generates all possible slopes provided x value. And now we can say x equals 3. You go, okay, that's 4 times 3 minus 3 is equal to 9, which is what we had before. This is huge. This is the essence of everything now. We started with the individual calculations, but this particular calculation, when we have x plus age, gives us a function which generates all possible slopes. And that function is called the derivative. So in a nutshell, what is the derivative? The derivative is a function which generates or calculates all of the tangent line slopes. We still don't know why is that so important. I'm just telling you it's damn important, really important, right? It's like Newton is immortal because of this. He didn't even know what the logarithmic function is. He didn't know what cosine x is, all right? You know, in some sense, more mathematics than he did already, all right? But he figured this stuff out. So the derivative is a function which which calculates all of the tangent line, all the slopes of tangent lines which you can possibly find for the given function. This function changes as soon as you change the boss function on top, right? If f of x is no longer 2x squared, whatever we had, if it becomes sine x, the calculation changes and the outcome changes. But the idea that that function at the end calculates all of the tangent line slopes stays the same. So calculation changes and you get this. So now, if I want to compute the slope at 3, you plug 3, you get 9. If you want to calculate 5, 20 minus 3 is 17. You calculate slopes like this. You don't have to go through the whole procedure. Because remember, if I change the number from 3 to 5, I have to redo all of this, right? To get to a different value, different than 9. Because, as you can see, we plug 3 into the problem itself. So this problem becomes exclusive to that 3. But now, with this thing, we calculate the general derivative, and then you plug in 3, you plug in 5, you plug in 1.5 or 10, and it just keeps spitting out the tangent line slopes. Yes?
So, knowing that, if you had like a function for like the trajectory of an object, wouldn't you be able to find out the direction with like what you just said, being able to find all the tangent lines? Would you be able to find the direction of the object at any point?
Not the direction. The direction is the trajectory. So if you have a car on a road, provided that the car is on the road, that is the path of the car, so the function.
Okay.
What you can find is its speed, the velocity. Because the tangent line, it will be the tangent vector which shows the velocity. So eventually I will draw things like this. Well, actually I can probably draw things like this already. This is the puddle with leaves and ice and everything in it, and oil, and you have a car going a little bit too fast here. There will be a tangent line, and that's the direction in which the road will continue this way. The tangent line will show which way the car is going to go. Because as soon as there is no traction between the tires and the road,
The momentum is just going to carry it.
yes, but which way? The tangent line way. Anything that it's done like that, or throw a baseball or whatever, the initial throw is going to be the tangent line vector. The ball is going to do this, but the initial velocity is going to go the way with the tangent line, which is the way you throw.
So that was the whole point of all that 2.1 crap. The book. I was going through that.
This is 2.1 actually, but I don't understand why they split it that way. Because at that point you don't know limits, you're not introducing derivative, so what the hell they were trying to achieve, it's beyond me.
Yeah,
So technically we already covered 2.1 with all of this long time ago. All right, so now the function in the answer is called the derivative. Notation: f prime of x, or dy dx. dy dx is better, so we'll use that one most of the time. That's Leibniz notation, by the way. Leibniz came up with calculus independently at the same time when Newton did. So they had a lot of debacle who owns calculus. They actually both own calculus, and Leibniz has a far superior notation. We'll see that down the line. Dy dx notation is far superior to f prime. Actually, Newton didn't have f prime. Newton had f with a dot. So y dot. That's how Newton had it. And you will see some mechanical engineering textbooks are still using this. And if you look into any of the older dynamics textbooks, like statics and dynamics for engineering, you will find angular velocity and angular acceleration. So angular, and then like that, and then like that. So we'll talk about notation later, but this is the Leibniz notation, and most of the time we'll be using this one because it's far superior. But then when we feel lazy, obviously, we use this. Or when we don't have to emphasize certain things. There is even the worst ones, like y prime. That's the laziest you can possibly be, right? To write just y prime. And we will actually use that in exactly one lecture because we won't care. So now, we write f prime of x is equal to the limit h goes to 0, f of x plus h minus f of x divided by h. And if you want a cool tattoo, there's your equation right there.
If I have the commitment to get that tattooed on me, will you not care if I use it to cheat?
No, I won't. Anything that you tattoo on permanently on your body, it's nothing I can do. If you write it with something that smears or is one of those temporary tattoos, then you're cheating because it's removable stuff. But I mean, if this is tattooed right there, what can I do? It's nothing.
I'm gonna have to call my artist when I hit Calculus.
Wait, so what if he has it tattooed? Can I look at it?
You have a really good eyesight, I might have.
I'll just move up to it. Is it that?
I think you'll have some competitors for those seats. Those will be hot spots right there next to it. And judging by the surrounding over there and the head nods, I don't think you actually have a chance. that chair would be populated before you even blink over there. See, look at that. It's like ready to move over. Yeah, so any tattoos, you can use it. Nothing I can do about that. I just want to see that when you walk into the shop and say, how much to tattoo the definition of the derivative? And the guy goes, huh? Just don't ask them to recall that stuff. Just show them on the paper. Yeah, you don't want a wrong equation tattooed in. It's not as something that you can just erase. I think they have to cut off your arm and then you have to grow a new one. You want to replace it. I don't know how that goes. Is that?
Seems accurate, I mean.
Yeah, pretty much. We have the formula for the derivative. So let's calculate some derivatives now. Let's find the derivative. For f of x equals let's just go 1 over x. Easy. Start somewhere. So plug everything in. And I will remind you that at some point during the class, we did the example that actually fixes this.
You have 18 seconds.
Did you find the example? 2.3. Same thing. 2.3. It's the last call for cupcakes. I gave you the fair chance. So you set up the limit age goes to 0 of 1 over x plus age minus 1 over x over age. That's the setup. You know how to set it up. It's just plugging stuff in. That's your pre-calc 1. Function composition for the plus age part. And then you just follow the algebra. The only thing you can do is to add fractions. I believe the problem in 2.3 that we did in class was 5 over x plus age minus 5 over x. So now instead of 5 you have 1. It's the same problem. Go on. I'm busy. Good job. You made it. Professional. So that was enough time for you to solve this. Limit h goes to 0. When you add these fractions, the common denominator is x times x plus h. In the numerator, you have x minus h. You can put h over 1 in the denominator because you will have to use double fractions to solve this. The numerator, x's die. You have that negative h. So it becomes 1 times negative h is negative h. And in the denominator, you have h times x plus h. So you multiply two that are close by and two that are far apart. That's how you solve this. Now h dies, and you have your derivative. So it is limit h goes to 0 of negative 1 divided by x plus h, and when h goes to 0, you get negative 1 over x squared. Yes?
One thing that's confusing is like, why is it 1 over x plus h instead of 1 over, like why is h in the denominator? If you plug in,
Are you talking about this one here?
yeah, and not just like to the side, plus h.
Because the function composition from pre-calculus, f composed with g, also known as f of g of x. So you are replacing x with x plus h. So if I have f of x equals 1 over x, I can have f of 3, that will be 1/3. I can have f of negative 7, that will be negative 1 over 7. I can have f of a, which would make it 1 over a. I could have it f of x plus h, which would make it 1 over x plus h. I am taking this out and replacing it with whatever is entirely in the parentheses. Usually what I do is to make it a little bit, dramatic. I say f of the flower is 1 over flower. I don't care what's in parentheses. It's going to replace the entire denominator because that's what x is. But then it could be far more complicated. You could have that f of x is equal to x plus 3 square root of x divided by sine x. The thing that we have to know is that every x needs to be replaced by, in our case, x plus h. So f of x plus h in this case would be x plus h plus 3 square root of x plus h divided by sine of x plus h. Bueno? Excellent. Now that we are at the topic of the square root, right? Right. Find the derivative of f of x equals 3 square root of x. Let's see what you get while I meet my destiny. You have about 7 minutes at most if you want to try cupcakes. Six now. What is the only thing you can do?
Take the X and the B.
What's the only thing you can do? Anyone?
You can rewrite the numerator as the cube root of. No.
We are going to rationalize. That's the only thing you can do. So here's the step. Oh, I forgot the 3 over here. No one said anything. So rationalize. 3 x plus h minus 3 root x root x plus h. So just follow the algebra from here. And you should be able to do it quickly.
So that's 3 square root of x, not cube root.
Which one?
F of x, is that equal to 3?
Yeah, 3. It's not a cube root. It's a 3 times root x. I don't know how to write. You could factor this 3 out, actually. Then you don't have to use it, but yeah, whatever. And now you see on the in the numerator when you in the numerator when you distribute the 9x and minus 9x cancel, and then the numerator will have h and denominator have h, they cancel, and the problem is done. 9 will cancel the 3 on the bottom. There's a lot of cool things you can do. It's a little bit of writing, but you get used to doing this when you do enough problems. So you are left only with 9. Denominator has, you can factor out 3. Then they cancel. And when you send age equal to 0, all you get is 3 over 2 root x.
How'd you change the denominator to 2 root x?
The age is 0, so you have root x. Oh, that's supposed to say. That's supposed to say plus everywhere. Oh my god, it's a conjugate. There's a minus here. Because there's a minus here, all of these need to be plus. So that's a plus, and that's a plus. Thank you. I didn't even see it. These cupcakes are too powerful. It's the conjugate. Conjugate is when you change the sign, right? In the middle. So that was a minus, that is plus. Propagate through the problem. So with age being 0, you have root x plus root x is 2 root x. So 3 over 2 root x. I do these problems mechanically. I actually don't think about this at all. Like, I put 0 effort into this to solve this problem because I've been doing this for years. And I know actually what the answer is going to be because that you will learn faster techniques of taking derivatives. This is not how we're going to take derivatives till the end of the course. This is today with limits, and then already in 3.3 you learn rules of differentiation, which is the shortcuts. So you know how you don't say 5 plus 5 plus 5 plus 5 plus 5 plus 5 is 30? You memorize 6 times 5 is 30, right? You will memorize that the derivative of root x is 1 over 2 root x. And you had 3 of those, so that's why 3 times 2 root x. So I know all of these answers, and then I make these silly mistakes because I'm really not paying attention at all. It's just, but good thing you do. So yeah. Awesome. Let's take a look at one more example from the textbook, from homework. Take a short break and then take a look at a very short lecture afterwards. It just deals with the relationship between the graph of the derivative and the graph of the function and how they're connected and so on. So let's see. So this is the problem from the textbook. They want to find the tangent line. So find the tangent line for function y equals 1 over 3x minus 1 at a is 2. So you should find the derivative, right? Find the derivative using your using what we just learned, and then when you have the answer, the derivative, plug into it to get the slope, and then get the rest. One thing at a time. So first, find the derivative.
going?
You.
See, I just struggle with. I don't know how to solve it. Like, I just don't know. So, do you multiply everything by
You didn't-
3x minus 1?
You didn't set it up right. You see how you put plus h at the end?
Yeah.
It has to be x plus h.
X plus h.
Mm-hmm.
But x is 1 over 3x minus 1.
That's
So
a
it should
function.
be 1 over 3x plus h minus 1.
Minus 1. That's why it doesn't work.
Okay. And then you just multiply everything by 3x plus 1.
This is the common denominator. They're both different. So it's gonna take.
3x.
Let me see. That's it. And now you cross multiply, cross multiply.
Don't forget to write limit in every step until you are done using it. So the common denominator is 3x minus 1 times 3x plus h minus 1. That's the common denominator. And then in the numerator you have 3x minus 1 minus 3, we have to put in brackets, 3x plus h minus 1 close bracket, everything divided by h. You can put over 1 if you want to fix it. So its limit h goes to 0. So what do you have? the numerator will be times 1 and these two guys together. So it's 1 times, so what do I have up there? I have 3x minus 1 minus 3x minus 3h plus 1. And in the denominator I have h times 3x minus 1 times 3x plus h minus 1. So now a whole bunch of stuff cancels here, right? This is done, 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 and done. And all you have is this h, but then h dies as well now. And you are left with the limit h goes to 0 of negative 3 divided by 3x minus 1 times 3x plus h minus 1. Now when h goes to 0, you have identical parentheses, so it becomes negative 3 over 2 times 3x minus 1. So slope m is going to be negative 3 divided by 2 times 3 times 2 minus 1, because they want that at 2. That's negative 3 divided by 6, 5, 10. Negative 3/10. That's the slope. So that's just the slope, right? Now you have to find the rest. You have that the x value is 2. You need to find f of x when you plug in 2 into original function to find y. So y would be f of 2, which is 1 over 3 times 2 minus 1. That's a 6, that's a 5, so 1/5. Y equal mx plus b. You have y, which is 1/5. You have m, which is negative 3 over 10. You have x, which is 2, and then plus b. Or you can use point slope formula if you like it better. 2 and 10 will cancel down to a 5, so you have 1/5 plus 3/5 is b. So b is 4/5. And the tangent line is y equals negative 3 over 10x plus 4/5. Tangent line. Boom.
I have a question.
What's the question?
Well, the original function is 1 over 3x minus 1.
3x, yes. The original function is 1 over 3x minus 1, sure.
Then that, the 3x minus 1 has an exponent of negative 1. So when you got negative 3 over 2 times 3x minus 1, how does that so? Does it use the power rule?
Wait, what did I do?
Yeah. Does it use the power rule? Does it use that negative 3 over 2?
Oh my god, I added them instead of... It's a square there, not 2 times. I quit. Alright, let's just go home. This is becoming much better. There we go. It's 25. Well, that doesn't change much, just everything. Yeah. Yeah, I was just testing you to see if you're paying attention, and you pay attention, so that's good. All right, so apparently today is the day to make all of the mistakes. Well, you know what? Let's just get that out of our system, and then... So 1/5, that's 5 over 25 plus 6 over 25. I have 11 over 25. I hope I can still at least add. I hope this is good. we can ask our friend Mathematica to verify this. And I'm just going to spell tangent right this time. Maybe I should start this is a good class to start a tally on mistakes. I'll see if I can beat this. Because so far I have 4 plus the technology meltdown, right? But I'm not responsible for technology meltdown. That's the network died. There we go. Okay, so let's quickly check. Tangent line for y equals, and what was the function?
1 over 3x minus 1.
At x equals 2. So this is all we need to write. And there it is. 3x, negative 3x over 25 plus 11 over 25. They just swap it. So as you can see, that worked. You can also see the graph for original function and observe that the original function is moved, right? So you see how the asymptote is shifted because the whole problem is shifted. And you have a tangent line there at 2, which is touching the function at exactly 1 point. It doesn't cut through it, it just touches it at that point. So everything works fine. If you find enough stamina, obviously, you will be checking every problem you do with this to make sure that it's correct. But, you know, you are still using the software, so the software will also tell you if you are right or wrong. Good. Well, that's it for the introduction. I just want to repeat one more time, that the idea of the derivative is to find the function which computes all of the possible tangent line slopes. And as you start changing this a value from number to number, it's much easier to plug it into the derivative to find the slopes than to redo the whole limit procedure over and over and over again. So the limit definition of the derivative is the formula that you will have to know. And as I said, you have seen these calculations in 2.3. The goal of today is not to learn how to take limits, because that's chapter 2. The point of today is to define the derivative as a difference quotient, the limit of a different quotient, and a different quotient is actually just a different way of writing the slope of the secant line, which is the algebra way to find the slope if you have 2 points. So now we learned that there is the tangent line is the limit of the secant line as the one point approaches another. And we learned through iterations that we can have, instead of figuring out 1 point at a time, we can figure out the function that generates all of the slopes. We call that function the derivative. And if I'm to say define the derivative, this is what you write, because this is the definition for the derivative in terms of the limit of the secant line. So limit of the secant line is the derivative. And that takes care of this. Now, we are going to replace this procedure very soon in 3.3 by memorizing shortcut methods. So you will have a choice of not learning any of the shortcuts and just do this every time, or learn the shortcuts and actually be much more efficient. That takes care of this section. We'll take a short break and then we are going to